Well, I guess I'll go ahead and get started. It's after 1:40, which was the start time, right? You recording? Good? All right, cool. All right, so this talk is Responsibly Abandoning an Open Source Project. Kind of wondered if I should have just named it Responsibly Abandoning a Project, but we'll see what you all think. And that should not be selected. Let's click that. So my name is Jason Turner. I need to not camp right here, apparently, because the camera's trying to track me, but I like to pace a lot. I have this YouTube channel that I've been doing for a long time now, over 10 years straight, and I am an author, best practices books, mostly focusing on C++, that is my specialty, and code quality are the things that I like to focus on. I am a developer as well, if anyone's interested in any of my GitHub projects, and I've been a Microsoft MVP for 12 years now. Assuming they renew me this year, I actually don't have the word on that yet. All right, so yeah, I do training. Now, traditionally I've done C++ training, but I am kind of looking into thinking that maybe I want to extend this a little bit into just general, like code quality and best practices kinds of things, just so you know. If anyone cares, that's a QR code for finding out more about me. My motivations, the world runs on software, right? Like everything runs software today. Like how many devices are in your pockets or on you right now that's got software? Watch, cell phone, I'm holding this thing, which has got some kind of probably embedded C or something. Although if it was running embedded Python, that would be more exciting in a way. Have you ever had to reboot your toaster? I have. It is infuriating, right? You shouldn't have to reboot your toaster. So I want to live in a world with better, safer software, cars, spacecraft, and toasters, okay? So this is why I do what I do. Since, I don't know if any of you have heard of my YouTube channel or anything before, I've given away like a lot of material. I also have had a C++ podcast off and on for the last 10 years, blog postings, many conference talks, and this kind of thing. This is why I do this. And also why I focus on best practices. All right, so I say avoid sitting in the back, but whatever. Do interrupt me and ask questions, yell things out. We're going to have a good time with a small group of us in here today. We'll see how long this takes, because it'll depend on how much interaction you give me. But in general, this is also what my training looks like, if anyone is ever interested in that. All right, here's the deal. Have you noticed the photographers that are going around? Okay, I know the photographer who's going to come to this room. If you all play along with me, when he comes in, I'll point him out. Pretend like you're taking his picture back, all right? Can you play along? You don't have to actually take his picture. All right, we'll keep going. All right, so responsibly abandoning a project. Now, imagine that you have worked on a project for 10 years. You accomplished every single goal you set out to accomplish with it. There are no open bugs. You decide to move on and work on the next project. Have you done this before? It's interesting to get to a point where you're like, yeah, basically I don't have any bugs left that I care about. 12 months later, someone says, is this project abandoned? There hasn't been any work on this thing in like a year, right? So, no. Slide missing, not missing, but skipped. All right, who has said this? Well, I would use that project, but unfortunately it hasn't seen any updates in over a year, so it's not worth adopting. Have you said this? Who has said, that library works perfectly for me, but the developers stopped working on it, so I'm not going to use it in my next project? Yeah? You've all done this? Okay. It's a shame that this perfect project has been abandoned by the developers. Everyone said this? Okay. Who has said this? I am so glad Microsoft changed the start menu. No one? Huh. Who has said, Google search just keeps getting better and better? No one? Huh, okay. Who has said, I wish companies would just leave things alone that work? Yeah? That's basically what we all say, right? So why do we carry this contradictory view? Why do we say if the open source project hasn't been touched in a year, it's abandoned and not worth using, but we wish that Microsoft would stop touching the software that we use? All right. No, that's what I just said. All right. So I really think that this comes down to a single issue. And the issue is you have someone to blame if something goes wrong. I think that's what it comes down to. Do you agree? All right. So a bit about my development experience. I've been a hobby programmer since 1985, which makes me feel really old. I've been a paid programmer since 1997. My hobby-only experience, things I have not been paid to work on, is many flavors of BASIC. And I feel like you have to feel particularly old to know the difference between QBasic and QuickBasic, but there is a distinct difference there. And JavaScript, HTML, PHP, hobby programmed with FreeBSD, Haiku. Who's ever compiled a program for Haiku? Do you know what your Haiku is? You do? Do you know what BOS is? No? Okay. Well, I mean, if you know what Haiku is, you know what BOS is. Yeah. So BOS was it was the hot thing around 97, 96, 97, right when I was starting university. And anyhow, it was abandoned by the company. The company went out of business. Their assets were eventually bought by Palm, actually. And wait, yeah, that's right. I don't have that backward. Well, somehow those two companies' IP ended up in the same place. And anyhow, Haiku is an open source reimplementation of BOS. It's a hobby OS for most people. All right, the Motorola 6500, 6502, the CPU, which has been used in many, many devices. Motorola 68K. For my professional experience, VB6, .NET, C++, C, Ruby, something like 13 dialects of SQL, C#, Java, Python, and like 5 lines of Fortran. I was paid to do it. I'm putting it on my resume, right? You have to be careful about that sometimes, though. Otherwise, the recruiter gets you because you have that one line of experience that no one else has, and you're like, stop emailing me. Mac OS, Windows 98 through Windows 10. I haven't been paid to do anything since Windows 10 on Windows. Linux, various OS-less embedded devices, Android, iOS, Solaris. And just for the, well, yeah, MIPCL, x86, 32, 64, ARM 32 and 64, Spark, PIC, okay? So I'm going somewhere with this. But the vast majority of lines of code that I've written have been open source in some way, and we'll get on that in a minute. Even the lines of code that I've been paid to write, most of it's been open source. Just a little slideshow, Commodore, TI. This, just for the record, TI-99, not a calculator. I have this conversation with people from time to time. That's a calculator. TI-81, Tandy 1000, good old Packard Bell days. That's a Spark Blade, you know, Mac OS. I've written software that ran on a hacked one of those, and various Palm and the PIC-18F series there. It's good times. All right. I just felt like I had to put a slideshow in there to make sure everyone was paying attention. Okay. I've been actively developing open source software since, I would say, at least 2008. To say earlier than that would maybe be a little disingenuous. Various small projects, but 2008 is approximately when I was serious about it. And from 2010 to 2023, I was paid to work on various US government-funded open source projects. That's the hence more about this. So when you're working on an open source project, and you know, like, this gives you certain requirements and constraints that a closed source environment doesn't have, because you know if someone wants to pick up your project and use it, they have to be able to compile it on their system easily, right? Which I don't know, who actively works on open source development? If you came to this talk, only one. Well, thanks everyone else for coming. What brought you here? No. Well, if your process for getting set up on the new project in your closed source environment at work is like, a Word document with like 15 pages in it, and this is how you set up your build environment, this does not fly in the open source world, right? Literally no one will use your project if you're going to do this. You have to have something that's got an easy to set up system. All right, so this is getting to the meat of this. I actively developed a project called ChiScript along with a few other people from 2009 to 2019, little bit more than 10 years. I'm going to go out on a limb and assume none of you have heard of ChiScript. Okay. It has users. So ChiScript is an embedded scripting language designed for embedding in C++, and it is actually literally this easy to use. Just for the record, I'm not encouraging you to use this project. I don't even know if any of you are C++ developers, but if you are, I'm still not encouraging you to use the project, because there's something about being a hobby open source developer is that users actually just cost you time and money because you have to support them and they never give anything back to you. It's the sad fact. And then I didn't never have a ton of users, but I do have users. Every now and then people come up to me at a conference and be like, thank you for ChiScript. And I'm like, you're welcome. So just this simple, I can say I want to expose this function, hello world, to the scripting engine, and I want it to be named hello world. So C++ does not have reflection until C++ 26. So you kind of have to be explicit about what you want to name this thing. And then this is a raw string literal right here. I want to eval this script, and I want to say puts the result of hello world, and this thing would print hello Bob, exclamation point. So it is like literally a one-line include and a one-line to start adding functionality to the scripting engine. It set itself apart. No one else was doing something this simple to use back then. There's a couple of competitors, if you will, today. Right. Meant to be a more natural drop-in for C++ than Lua was. Naturally bidirectional full language support as much as possible between C++ and script. Some of the things that I set myself apart with here is you can throw an exception in ChiScript and catch it in C++, or throw an exception in C++ and catch it in script. You can create a function object and script it and use it from C++ and vice versa. We tried to be as magic as possible. Comes with a huge compile time cost, for anyone who's curious. This thing just works. In 2017, I started porting ChiScript to C++ 17. In 2019, I got fed up with how long it was taking compilers to support C++ 17, so I dropped ChiScript and I walked away. To this day, the project is still alive, with almost no interaction from me. But I do get people who still say, is this project dead? And I tell them, no, it's not dead, it's finished. But we'll get to what I mean by that. All right. I have seen a lot of mistakes in my career, and I have made a lot of mistakes in my career. Does anyone happen to recall when I first started doing software development as a hobbyist? 1985. And I started being paid in 1997. Keep these numbers in mind. I didn't write automated tests for professional code until 2010. Worse, I was the junior on a team where we acted like the one person who was writing tests was wasting time. I apologized to that guy a few years ago, just for the record. So this talk is a summary of my experience of 17 some odd years of open source development, plus my other experience here. All right, the topic at hand. How do we convince users of our projects? And I say open source, but I want to lump internal tools in here as well to say this thing is complete. It's not abandoned. It's not legacy. It's completed. And further, how do we set up our projects so they can be picked up by anyone in a future date? So I'm going to ask you, and I'm going to test a new feature of my slide system. That's legible, I think? Yeah, okay. What is your primary language? Anyone? C#? All right. Oops, not CW. That's a TV station that's defunct. Anyone else? Rust? Oh, someone who works in the compiled languages. Hey, you're not supposed to be in my photography today. It's supposed to be the other guy. He's coming too. All right. Rust. All right. Well, C# is a compiled language also, but I meant systems language. Anything else? C#? Python. Anyone else? Different? Kotlin. Oh, okay. All right, Python. So you like the JetBrains people? You have to. Have you ever met Phil? No, it's the other Phil Nash, not the Phil Nash who's here. Other Phil Nash is involved a lot in Kotlin and worked for JetBrains for a while. Okay, anything else that I should put on this list? Okay, these are your primary languages. Terraform? You know what? For the sake of this conversation, I don't know what Terraform is. What is Terraform? It's what? Infrastructures? Okay. I kind of include everything, and for the bigger picture here, I'm even going to go so far as to include JSON, HTML, whatever, and maybe that'll make sense in a minute. All right, we can come back to those notes. So yeah, I just made some guesses here: Python, C#, TypeScript. No one said TypeScript. I think I saw one example of TypeScript somewhere in the last 2 days. I don't remember where it was. C++. I'm the only C++ developer here. See, I didn't guess Rust at all. Sorry. All right. So our general requirements for any project at all. Proven. This is going to, trust me, as we get through this list, you're going to say this sounds weird, but I have a point to it. Proven, maintainable, resumable, provable. I'll get to what that means, why I have proven and provable, and writable. So, proven code. Linted, tested, and analyzed. Linted. So linting, or also called static analysis, refers to tools that analyze your code without actually executing it. This can include your compiler with compiled languages. And I'm going to have to spend time now right at I'd like to wander, and now I feel like I'm anchored with my keyboard because of where I'm going with this. So, do you use static analysis tools currently on your project? So this is something that analyzes the code. And this is why I would say I would include JSON and XML and whatever, because if you've got a schema with your JSON or with your XML, then you can validate and prove that your thing matches the schema. That is a form of static analysis. Also, running tools that verify that you have properly closed your tags or whatever. This is a form of static analysis. So anyone want to share any static analysis tools that you use for your language and tell me what language you're using it for? Graph? RUFF, okay. And that's under Terraform or? No, Python. Oh, yeah, okay. That. All right, cool. And look, I can do like, we can render the markdown too. It's very exciting. Just for the record, Claude added that feature for me yesterday. Right, Clippy and Rust. So we'll get to Rust format maybe later, because format literally reformats the code. It doesn't do static analysis, right? Okay. Okay. All right. So Clippy, and Rust. What is that? Like a dash FMT. Like that? I know people who are Rust experts. That does not make me a Rust expert. All right, any other static analysis tools? This can include the warning levels on your tools. So C#, I believe, has warning levels that you can turn up when you compile the code. Do you use extensive warnings? Rust bin? Okay. And did I hear that right? Rust bin? Oh, ROSBYN. Okay. Well, I don't know. Under C#? All right. Anything else? Anyone like to share? Yes, for Python, there's a lot, but there's only like maybe 2 I feel like that are like considered industry standard kinds of things. And I'm not going to try to sell any products here because I don't have any skin in this. But most of these languages are supported by Sonar family of tools. I may as well just mention that. They have static analysis for this. Does anyone notice Kotlin have static analysis tools? Okay. Okay, code inspector? Like something like that? Okay, all right, cool. So for your compiler or interpreter, there is, I mean, like even like Python, well, we can turn on other kinds of warnings with Python as well. There's the warnings from our compiler or interpreter that can be added often. How easy is it for you to run these tools? How is your environment set up? Do the tools run automatically? Does everyone agree these tools run automatically? All right. Are warnings treated as errors from your tools? Then they're ignored. I'm sorry. This is just too much experience working with humans. If you don't have something that's going to beat you in the head with your warnings, then they're going to be ignored. All right. C++ compilers specifically have like so many warnings that can be enabled. And so I find myself not saying turn them up as high as absolutely possible because there are warnings that are generated by our C++ compilers that are not actionable by us. They are diagnostic. And they can tell you things like padding had to be added to the end of the struct for ABI compatibility or something. You're like, I can't do anything about that. Thank you for letting me know. Let's move on with our lives. So not necessarily 100% of warnings, but close to it. Type checking. Who said Python? Everyone's a Python programmer, right? Let's be fair. Really? No, you raise your hand if you do some programming, like are paid to do some Python programming. Really? Only like 3 of you? That's weird. And I'm just used to like more like 100%. Do you actually use the type check? Do you do type hinting? Do you use the type checker? Okay, most Python programmers that I know, they're like, oh yeah, we use type hinting. Yeah. Do you run the linter to verify it? No. Then it's not doing anything because it's just a comment at that point. All right. So I am going to put up something here, and this is something we could spend a while on if we wanted to. Does anyone lean towards a strongly typed mindset? And I have a specific example up here if you don't know what I mean. You do lean towards strongly typed? Yeah? All right, let's see how deep this goes. You know what? I thought I reformatted that. Well, I'm not going to edit it live right now. But who prefers the thing on the left where we've got int x, y, z, and that's supposed to be BGR, versus the thing that's got a point and a C, so a point and a color? Who prefers? Who prefers the thing on the left? The photographer's here. Come on. They're slow on the hook. I tried to get them set up for it. It's just would have been better if it was like a big room and everyone had pulled their phones out at once. Yeah, okay. I'll get you in Norway. All right. Who prefers the thing on the left? Who prefers the thing on the right? Okay. This is maybe a somewhat obvious one. Now I've gone one level deeper. Who prefers the thing on the left? And have you gone this deep? Who prefers the thing on the right? You see what I've done there? I've done two things. The first thing is that I've made, it's not shown here what the declaration looks like, but I've made some sort of strongly typed X, some sort of strongly typed Y. All right, with the point, of course X is before Y. With the color, do you see what I did? This color represents BGR instead of RGB. There might be a reason for this. Maybe I'm talking to hardware. Maybe I need to write something directly to an LCD panel. I don't know, right? So the thing on the left, I just can't. It's every time. The thing, how many pictures I have like this too. The thing on the left is possible to screw up because the user of your library is probably expecting RGB. And I could have named this thing color BGR if I had wanted to, but the thing on the right makes it impossible to get the order wrong. So thing on the right is where I'm leaning more and more in my career, personally. The thing on the left is what most people do, basically, at this point. Yeah. Apparently those should be like float 16s or something, actually. I don't know, whatever. Okay. So I already asked you this, if you had a favorite linting tool. We've already done that edit. All right. Tested. Unit test, behavioral testing, integration testing. Does anyone have a personal preference, a philosophy, anything that you care about here for testing philosophies? It is warm in here. So unit testing is like, I'm going to just test a function. Behavioral testing and integration testing, I would say probably have some overlap here because behavioral testing is some people call it behavioral testing, some people call it like a gold testing or regression testing, depending on your mindset. And, I'm confusing something else here. Sorry. Behavioral testing is not what I meant to write there. Well, anyhow, the idea of like, I'm going to treat my software like a black box, and I'm just going to verify that the output is what I expect it to be. And integration testing also is going to work with multiple components at once, where unit testing, functional testing are digging into individual functions. People usually do a combination of these things. Do you have a favorite test framework that anyone would like to add to our list of things that we're building? PyTest? Yeah, that is the de facto standard one, right? I mean, that's the one that kind of ships with Python. Oh, okay, all right, cool. All right, PyTest. I'm assuming that's how it's spelled. Yeah. Anything else? Yeah, the one that's not called new. Rust has one built in. What are you going to say? MOQ. Oh, and that is for C#. Yeah, okay. All right. Okay. Anything else that, and so the Rust one is like, something like that, right? Anything else? JUnit. Wait a minute, but we don't have any languages up here that start with a J. That's Java, right? Yeah. JUnit ended up inspiring and oh, that's because Kotlin compiles to the JVM, right? Is that right? Okay, I'll just do that then. JUnit, Java, Kotlin, yeah. JUnit is old, like in a good way, and inspired a lot of other testing framework and tools that exist today. Okay, do you measure test coverage? You do? Ooh, this is one of my personal soapboxes. I love talking to students about test coverage right now. How do you measure test coverage? Yeah, but do you care what kind is the camera's magic? It follows me. Do you care what type of coverage? Do you know what I'm talking about? There's 3 different ways to look at coverage. Right. Line coverage, branch coverage. Let's do this. See, I can't stay on the stage. I apologize to the people later. So how much testing is enough? What line of code coverage do you care about? Or branch coverage do you care about? Or path coverage do you care about? So let's take this example. I have my test case on line 14. What is my line of code coverage right now? Not including white space or braces, right? Meaningful line of code coverage. Most tools are going to filter out the brace lines or whatever. I'm at 100% right now. This one test case gives me 100% line of code coverage. My job is done. My project is perfect. I can go home, right? What? No? Okay. So yeah, I have a click through here. All right, the example on the left is what we just talked about. It's got 100% line coverage, 50% branch coverage, and 25% path coverage if I've done my math correctly. So I added in the empty else blocks just so that we could visualize the branches that weren't taken, okay? And now the thing on the right, I've added a second test case, and now I have 100% line coverage, 100% branch coverage, but I'm looking at 25. That's not right. That should say 50% path coverage. It's taken 50% of the paths to this code. This is easy for us to compute theoretically because I've got 2 Boolean inputs and I've got then 4 possible inputs to this program. Each of those Booleans is used exactly once. So with the thing on the left, I am testing. Oh, I did my highlights in the wrong order. Darn it. All right, so the thing on the right, let's just do the thing on the right. I'm testing the true case and the true case, and then I'm testing the false case and the false case, but I am missing the true case, then the false case, and the false case, then the true case. And if that second branch right here somehow relies on something that happened in the first branch, then we can get real bugs in our code if we don't test all the paths. So I'm going to go to, darn it, it says 25% path coverage. This slide, does anyone measure branch coverage? No? Yes? Cool. Anyone measure path? If you don't measure branch coverage, you almost certainly aren't measuring path coverage. Path coverage is very expensive to calculate. And from what I understand from people who are actually experts in this topic, you don't look at path coverage in the system as a whole, because that's almost impossible. You look at path coverage through each function. All right. So, Missing, wanted to have a break here. Okay, so runtime analysis. And now this is where this is going to really get outside of my expertise and other programming languages. As a Rust person, I know that you use the LLVM backend and you have access to some of the same sanitizing tools that C++ has access to, such as the undefined behavior sanitizer and the address sanitizer and the thread sanitizer. These are things that do runtime analysis of our code. And I can imagine that most tools, most languages have something, even if you say you live in a world where runtime memory errors are impossible unless you're running in an unsafe world. You probably have something that can possibly catch at least thread race conditions at runtime in your test suite. Does anyone have anything on this topic that they would like to share here? You should look into this for your language and tools as to whether or not there is thread race condition or any kind of runtime analysis. I kind of want to also put contracts into this. Contracts are a form of runtime analysis. If we say that path coverage is effectively impossible to reach 100%, but we want to aim for good path coverage, we kind of have to catch the rest of the potential bugs in our system, possibly as contract violations or assertion failures in other ways. Sanitizers, Valgrind, et cetera, in the systems programming world. No one has anything to add, then this becomes your homework for later to look up what runtime analysis might exist for your tools. Is anyone familiar with mutation testing? No. Ooh, this is fun. Then you're not going to be able to tell me what it is, but I can show you what it is. So this is my test case. I have my multiply function and my test. My test passes. I have 100% code coverage. Clearly, this code is correct. Yes? Okay. I'm like waiting for someone to respond. Interestingly, if you have an agent, it would probably spot this bug very quickly. This is mutation testing. So note the code on the left is the code being tested, so it uses like coverage analysis. The code on the right is the code the test code. And then the mutation tester will come through and it'll do something like swap an operation. Instead of a multiply, that's a divide, whatever. And then I see that my test still passes. This becomes a mutant that survived. And if you have a mutant that survives, then you know that your test is invalid and you need to fix your test. So it's a way of testing test and making sure that your test suite itself is comprehensive. All right, so no one has done this. Mutt, as far as I can tell, is one of the best supported mutation testing tools for any language. I could be wrong. Someone can also correct me here. I am currently, other than the list that we've been working on here, I am currently collecting a more robust set. There are tools like this for C++, for my main language, but they are kind of cumbersome to use because it kind of has to modify the C++ code and then recompile the project and rerun the test, and that is slow, right? Okay. Oh, stop doing that. My clicker bounced, button bounce. So I already said warnings as errors or they'll get ignored. And I'm going to stand by that. Does anyone has any warning tips for their tool chain that they would like to share? So for example, if you're a C++ programmer, Clang Tidy is one of our best open source free static analysis tools. Clang Tidy is largely maintained by Google developers, so it has a bunch of things that are like LLVM specific and Chromium specific and Fuchsia specific and Android specific. If you enable all of these, it's not good, right? I'm not Google. I'm not an Android kernel developer. There's no reason for me to have these warnings in my programs. They go against other best practices in some scenarios. So just be aware of this kind of thing. Or if you have something you would like to share, go ahead. I'll add it to the notes. Okay. So, maintainable. Are you using source control? You know what? I have not been teaching for that long, and I occasionally still have students that are like, well, I mean, once the project is like 2 months old, yeah, we move that into source control. And no, that's not how that works. All right, tests that run easily. Consistent style, auto code formatters. Let's do that. What is your code formatting tool of choice? We already mentioned Rust format can do some of these things. Does C#, do you use an automatic formatter for it? Do you know what it's called? Something. Python has a few. Black, right? Yeah. And Py what? Ah, okay. Kotlin, does Kotlin have code formatter? Something? I don't know. Okay. This I find, particularly if you're maintaining an open source project, having automatic code formatting I feel like is huge because that avoids any arguments. When someone opens a pull request and you're like, your pull request is perfect except for the fact that you're missing a close, the close brace doesn't line up how I want it to be lined up or whatever. And you're like, just run the auto formatter and then we can't have these arguments, right? It saves everyone time and pain. Lowers the threshold, the barrier to entry for these things. All right, favorite code formatter. Now, this is what I want to say under resumable, by the way. So I said, yeah. So I think that building and running all of your tests should be at most 5 lines for someone who's just getting started with the project. I know people who have their system set up so that whatever their build command is on line 4, that thing also runs all of the test and all the static analysis and all the runtime analysis and everything all in a single step. I don't personally go quite that far. I still have that as a separate step personally. But your project, if it's more than this, and notice line 2, that's kind of like, I didn't even need that, right? Line 2 is just a convenience line. If it's more than this, you need to simplify your system for building your test, building your project and running your test. Is anyone at approximately this good of a state? Does anyone have the 15-page document for how to get set up when their new hire joins? You're laughing. Yeah, okay. I've been there, right? I've been the new hire on the project. And to be fair, I guess sometimes if the system involves setting up a cross compiler so that you can build for ARM from your, Windows desktop or something. But still, don't do that. Try to do this. Now, I mentioned clean history in the resumable category before. Does anyone have an opinion? Like, what do you have when you do you do squash and merge? Or do you merge the whole history? Do you make sure that a branch stays to exactly one feature or bug fix so that the squash and merge makes sense? Or do you, one thing I hope that you don't do is have a long-running branch with 10 features in it and then do a squash merge of that. Like, that just feels unwise to me. But think about this, clean history, particularly if you're going to walk away from a project, so the people who come in after you have some idea what project is supposed to do, how it got to this state. Now, as someone who has been a huge proponent of using as many tools as possible, I do say use every single tool possible to ensure the highest possible code quality. But I am now going to modify my statement a little bit, and I'm going to say when you are ramping down on active work, you should perhaps pare down your tools to just the things that your industry considers to be the standard things. So kind of going back to this, perhaps, rough came up under static analysis, right? So perhaps you just run was it rough static analysis? Okay. Oh, yeah. So maybe for your Python, you run, I don't know, just rough or something. When you're walking away from the project. During active development, use like all of the things. But when you're walking away, limit it to just like the handful of things that are industry standards. All right. So your perfect completed project lays dormant for a while. Someone picks up the project to continue development. For reasons, they are required to update tooling. Like, for example, I walked away from TriScript in 2019. It is currently 2026. Compilers, operating systems, dependencies, libraries, everything has moved on. All the static analysis, everything has moved on. To try to go back to a compiler from 7 years ago just simply makes no sense. So these new versions of these tools are going to generate new warnings. The new warnings are going to break existing code because, remember, I have warnings enabled as errors. So this is why I'm saying kind of just notch things down just a little bit so that someone who comes to pick up your program later doesn't say, oh, well, I have to deal with CVP check and sonar and Clang tidy, and they're all giving me new warnings along with my compiler, and now I've got like 7,000 warnings from this code that generated 0 7 years ago, which actually pretty much did happen to me when I picked up TriScript this year, by the way. And so you just kind of try to minimize that friction just a little bit, all right? So yeah, I'm repeating myself with the slide bullet points. All right, now what I think is going to be possibly the most controversial thing here is I'm going to say don't use the archived feature of GitHub. This is, I think, as soon as you mark it archived, people, they associate this with abandoned. It's not abandoned, it's done, right? That's where I want you to get with this. So only mark it as archived if there is a proven successor fork. It's my opinion on this. Consider giving someone you trust write access when you walk away from your project. Now, if we're talking an internal tooling, then that doesn't make a whole lot of sense. But for open source GitHub and as a open source maintainer, I'm going to strongly suggest that you keep ownership for yourself until you're truly ready to say, I no longer care about this project. Because there's a very good possibility that if you give someone write access and then turn your back for a couple of years, when you come back, your project's going to be completely in a different vision than you ever had for the thing. And you might then be tempted to fight back control of it. Every branch, every pull request should be automatically run through the existing testing tools. This is for GitHub. This is easy. We've got GitHub Actions. Now, of course, the GitHub Actions themselves can break over time as you're forced to update operating systems. And then updating those operating systems will naturally update the tooling. So you'll just have to be mindful of that. But fully automate it so it's not possible for this to be overlooked. Require passing tests for your tools, and merges into main branch are allowed, right? You have to have everything pass 100% before you allow a merge. So if it's not actively maintained, there's a chance that the external dependencies will go stale, and then that itself will also make it hard for things to go moving again. In my world, I'm talking about even just the tooling that I rely on changing in ways that made it relatively difficult to get the project moving again. But hopefully all of your external dependencies follow the guidelines in this talk and they haven't all been marked archived and abandoned on GitHub. All right, so my summary here. Pretty good timing. Okay. Use source control. Automatically run every tool you possibly can. This is during development. Every tool you can. Aggressively build test coverage. Try to have as good a test coverage as you can. Use and analyze your stronger types. In your Python, make sure you're actually running the linter that actually tests the types. Utilize contracts, runtime analysis, whatever this means for you. Push fuzz testing as much as you can. I skipped the fuzz testing slide. That's all right. I've got a roundup slide in a second here. All right. Push mutation testing if your language supports it. Now, we are done with development. I'm saying I'm done. I'm walking away with it from it. Before I abandon it, again, this is summary. Make sure you're using source control. Automatically run the industry standard static analyzers, so we might pull back a little bit on the number of tools that we're running. Automatically run my test suite with whatever dynamic analysis is available for my tooling. Automatically report test coverage. Open source tools, I'm going to personally recommend CodeCov, which I think works with virtually every coverage reporting tool from every language, and it can automatically be pushed to from your GitHub action. You using CodeCov? Yeah, okay. Triage all existing issues. If you want to say, I've walked away from this project because it is complete, not that it is abandoned, and you have 300 open issues, no one's going to believe you, okay? Lock down the main and develop branches to limit how PRs can be merged. Maybe, I've done this with one project. I said, it must have approval from at least 2 other active maintainers before they were allowed to merge into main. So they had to at least fight with each other. After you've abandoned it, consider giving someone else the ability to merge PRs. Look in from time to time to see if there are major bugs developing. Look in from time to time to see if the community has moved on and there's a clear successor fork. Now, this is where you have to make a decision where you say, okay, now I'm going to archive my project. I'm going to say this project has been superseded by Bob's fork and everyone loves it. You can ignore me from now on. Or you say it's time for me to merge Bob's fork back in here. Just do something like honest and with community involvement and don't have everyone accuse you of like stealing someone else's work or something. All right, so how this played out with ChaiScript. During my phase 1 development, source control from the start, good test coverage. I was not tracking it very well. I used WAll with GCC, and if anyone has used GCC, just so you know, WAll is very far from all of the warnings. It is very poorly named. During phase 2, I started to get my first users. They ran a lot more testing and tools against our code than we did. So we got much better test coverage, went from WAll to WEverything, which is literally all of the warnings. CVP check, Valgrind, runtime analysis, static analysis. And then I said, this project is perfect. I've got good coverage with all the tests passing. I have all the static analysis with no warnings. I have all of my dynamic runtime analysis with no errors. So I knew it was perfect. And then I learned about fuzz testing, which I just realized I completely left out a slide as to how fuzz testing actually works. Who is familiar with fuzz testing? All right, pseudo-random input is generated for your program. It uses coverage analysis to try to guide the input to try to reach 100% coverage of your project. You cannot look at what the actual output is, because if you've been given a random input to your multiply function, you have no way of verifying what the expected value should be, right? You're just throwing it in there to see if you get contract violations or memory errors or anything else that can be tracked at runtime. So I learned about fuzz testing with my project that was already perfect. And how many runs did it take before I hit a memory error? 1. The empty string, a valid thing that was empty. And I never considered that someone would ask me to parse an empty script. Memory error. I ended up having to rewrite this parser that I knew was perfect. Fortunately, all this happened pre-abandonment, right? Like this is where I started to feel really, really good about this project. And there were no major outstanding bugs, which is why I was okay with walking away from the thing. So do as much testing with as many tools as you possibly can. Automate as much as you possibly can. And you know what? Everyone else is talking about AI, so I figured I'd put this slide in here. You can have an AI agent monitor your open source tools and be like, hey, buddy, did you know that there's a new error here, a new like bug report? You should probably look into it and comment on it. And so this is actually how I've resurrected ChaiScript recently. Is my handle is lefticus, in case you didn't see it at the bottom of each of these slides. And so I have created leftabot, and leftabot is running on a server at home. It's just a script that has, you can see leftabot. He's my avatar, but done up as a Cyberman from, Doctor Who, as one does. And this is the pull request that it created. No, wait, wrong. That's not a good issue for me to click on here. Let's do the add strong type dust feature. So there was an open feature request for a long time, and I was the one who opened it, and then I asked leftabot. I'm like, hey, can you work on this feature, leftabot? And it just automatically created a fork and fixed the feature for me. Opened a pull request, and then I had some back and forth with leftabot on the PR. Well, everyone's already clapping over there. We still got 2 minutes, people. All right. So I just had a conversation with it. Hey, leftabot, you should have added a to underlying feature, whatever, and it kept updating the pull request. It's been really actually super handy for helping me to get my open source projects that I've walked away. No, that was not meant to be a click. That I've walked away from, like back and running again. All right, I guess, I'll just mention, I'm working, I have C++ best practices books. I'm working on an update to this that's called Make Bugs Nearly Impossible, is the title of the book. And it's like all of this information and more. So you all kind of helped me organize some of my thoughts on that. If anyone's curious, it's not even for sale. It's just a placeholder for that book. But anyhow, that brings me to the end of this, responsibly abandoning an open source project, or just responsibly abandoning any project, or really just responsible development, I think. So that's me, and we're out of time, but thank you everyone for coming to my talk. If anyone has any other questions or thoughts or anything, you can ask, or you can come up. We've got like 1 minute left technically on the clock here. I also have stickers if anyone wants any. Oh, okay. Yeah, come grab a sticker. All right, thanks.